Hello students, in this video we will practice some questions on the topic motion in a plane. This chapter is very important from your exam point of view and has a huge weightage in exams. The following questions are for your practice for the chapter and are in line with the competitive exams. So without further ado, let's begin with question 1. Question 1 states a train is moving forward at a velocity of 2 meters per second. At the instant the train begins to accelerate at 0.8 meter per second square, a passenger drops a coin which takes 0.5 seconds to fall on the floor. Relative to a spot on the floor directly under the coin, at release the coin lands where? So this is the question. Let's solve it. So we have to solve this problem in reference to the frame of train. So relative velocity of coin with respect to train is 0 meters per second. And relative acceleration of the coin with respect to train is negative of 0.8 meters per second square. Here negative indicates that the direction is opposite to the train and the initial direction. Then, by using second equation of motion, we can write that x equals to ut plus half at square. So, s equals to 0 plus half negative 0.8 into 0.5 square. So, s is going to be nothing but negative of 0.1 meters. Therefore, the final answer is that the coin moves 0.01 meters towards the rear of the train. Sorry, it's 0.1 meters, so it's going to be 0.1 meters towards the rear of the train. So now let's move on to question number 2. Question number 2 states that we need to find out the magnitude of resultant of two displacement vectors, each having a y component of 10 kilometers, are added together to form a resultant that forms an angle of what? 60 from the positive x-axis. So can I write A vector as x1 I cap plus 10 j cap and B vector as x2 I cap plus 10 j cap? Now when A vector plus B vector is done, then the resultant is A vector, which is nothing but x1 plus x2 I cap plus 20 j cap. So 20 upon x1 plus x2 equals to tan 60 degree, which is equals to 0.87 upon 0.5. So x1 plus x2 equals to 10 upon 0.87 and mod of A plus B equals to under root of 10 upon 0.87 ka whole square plus 20 square, correct? And this is going to be what? This is going to be 23 kilometers. So it's going to be nothing but 23 kilometers. I hope you understood this. So let's move on to question number 3. Question number 3 says that for a projectile, the range and maximum height are equal. So we need to find the angle of projection. Now, let theta be the angle, r be the range and h be the maximum height. So can I write r equals to u square 2 times sine theta cos theta by g and maximum height h as u square sine square theta by 2g, correct? Now h is equals to r in this case. So I am going to write and equate these two. So it's going to be u square 2 sine theta cos theta by g, which is equals to u square sine square theta by 2g. So it's going to be 4 cos theta equals to sine theta, where tan theta equals to 4. Theta equals to 76 degrees. So theta is going to be what? 76. Let's move to question number 4. So question number 4 states, a man runs with a velocity of 8 kilometers per hour towards east. The velocity of rainfall is nothing but 4 kilometers per hour and vertically downwards. At what angle should he hold the umbrella so as to protect himself from the train? So first of all, let's draw the diagram. So it's going to be somewhat like this, that this is V of mg, and this has to be equal to what? 8 kilometers per hour, and this has to be vrg, that is equals to 4 kilometers per hour. Okay, and this is going to be nothing but vrm, where r is the rain, g is ground, and m is man. And we have what? V of rm is equals to V of Rg plus V of Mg. And the resultant angle makes angle theta, that is theta is equals to tan inverse 8 by 4 equals to 63.43 degrees with vertical. So man should rotate his umbrella in anti-clockwise direction such that it makes an angle of what? 63.43 degrees with the vertical. So it should be 63.43 with vertical direction, and that too anti-clockwise. Let's move on to the last question. So the last question states that two cars of masses m1 and m2 are moving in circles of radii r1 and r2 respectively, and their speeds are such that they make complete circles in time t. The ratio of their centripetal acceleration is going to be what? So now since both make complete circles in same time t, so angular velocity is also same for both the masses, right? So the centripetal acceleration is going to be nothing but omega square r, correct? So a1 by a2 is nothing but omega 1 square r1 upon omega square 2 r2, and omega 1 equals to omega 2. So a1 by a2 is going to be nothing but r1 by r2. So the ratio is going to be what? r1 is to r2. I hope you were able to digest all of it. Do try solving the test for this chapter on EduRev and check whether you were able to score full or not. Thank you very much.